Wherever you want to go.
All right. Hey, everybody. We're the Men in Black, and our project is called the Point2Point.
The tools we used to program this thing was HTML5, the Canvas element of HTML5, JavaScript, PHP, along with some help from jQuery and Ajax.
Our client is Dr. Aaron Collada, right over there, and I'm Rodney Garland, and on this project I worked with implementing the Ajax and doing a lot of the research behind it. General map work, where finding distances between nodes on campus map, test maps, that kind of stuff, and I worked with the Ajax, which we use to sync up the JavaScript and PHP code.
I'm Andy Gray. I work on pathfinding, implementing the A-star algorithm in PHP, representing positions as data on the map. And I implemented a solution to the traveling salesman problem, so that if you wanted to get from one place to another and stop at a bunch of places on the way, it would find the most efficient path through them.
My name is Wayne Henderson. It's kind of hard to see up there, but I did the website design for both the mobile and the desktop version. I handled a lot of the user interface that didn't have to deal with drawing elements on the canvas, and I did that. And I handled receiving, sending, and handling data that we get to and from the server.
I'm Nicholas Scott, and like Wayne said, focused primarily on the canvas, mostly the graphical display on the canvas, and the functionality. I basically did much of the core GUI design. I did things such as displaying the map to the user, being able to manipulate the map by dragging it, zooming in, and out. Also, placing the map, placing the points onto the map, and having the respective paths between each point in order.
All right, our goal was to create a functional and portable navigation system. I think the school has one. If you've already seen it, it's a Flash application on the website. But we wanted to make one that's a little easier to use for mobile devices. We also want to do this to assist current and future students while finding their way around the campus, because we all know how.
In the past, for our prototype, we mainly just had it displaying basic functionalities with the test map. We wanted to make sure we can get the map to appear to the user of our application. You can move it around, you can zoom in and out, and all the basic functionalities that we want to present to our fellow students, our client, everybody else. We had pathfinding with a simple grid. It was literally like 0 by 20, not 0 by 20, but yeah, not that big of a map. But we stylized it to where it had a grid overlay, and we were using the intersections to calculate nodes that we could pathfind through. So representing nodes on a map, you were able to place 2 red dots by clicking the picture of the map, and when you hit go, it would calculate the shortest path by traveling through the grid.
For our final presentation today, we've got our application displaying the map to the user in the web page, and we represented different points on campus as data in our PHP code, and represented them as nodes you can find a path between. And we've implemented a simple solution to the travel and salesman problem, and we have a custom layout for mobile devices as well.
And in the future, we'd like to implement a functioning map editor where other campuses can put their map together and put their own custom nodes so they can have their own pathfinding around the campus. Also, we'd like to add login functionality to keep it exclusive to the students, and also a native application for the Android phone.
All right, load program. Another good reason for having something like a login functionality to be available to users would be we could possibly have it to where students could upload their schedule, and then at certain times it could tell them via their phones or a text message or a sound or something that your class is coming up, and could show them where it is. So this is our loading screen. We worked very hard on it. It's a nice gradient. It's a big map. It's 7,000 by 10,000 pixels. So that might be another future implementation, loading it faster. So if you scroll around, you can see we have green for grass and parking spots and everything that's not a building. And then if you see over here, let's see, how can I do this better? All right, this is our user control. This is where our users can input where they're at and where they want to go. And Nick can demonstrate this real quick.
So say we want to go to defect, the entrance defect to the Katrina fountain. We want to add this to the queue. Here we go. There's start. Defect, destination, Katrina fountain. Say we want to go add a few more destinations. Let's say let's go to deployments too. Yeah. Here we go. So yeah, normal Katrina fountain and deployments entrance, and then you press go. And there you go. Automatically centers to your path and displays it to the user. It adds its respective numbers by the order of the destination.
You can add as many things as you want to the queue. As far as I know, it'll take every single node on there. You can delete things from the queue as well. They're next time demonstrate for you. Future functionality we plan on adding is editing items that are already in the queue. You'd be able to select something up there for your next stop and click an edit button in the thing. It would change your destination from the queue.
One of the biggest, I think, current problems we have right now, when it came to mobile development, like we said on the PowerPoint, we really wanted to throw it on an Android device or something of that nature so users can carry it around in their pocket. But the first challenge from that was our image is so big that loading it on a phone doesn't really work. So we were working on, like I said, making a better way to load it and stuff like that. So when we do go to develop it further and put it on an Android device, it'll be a better product because we really didn't want to put something unfinished and messy out there on the Android for 59 cents.
Also, if you check the traveling salesman box there, when you have multiple nodes between your start and your destination, it will look at the nodes that you put between the start and destination and find the most efficient path to go through them in the shortest time and still get to the same place at the end. If you want to understand.
Which point should
Defect center is a good start, continues is a good end. Everything else, it doesn't matter what's in between. Difference would be the last one.
check the box.
Yeah. And as you can see, it's decided that it should go to the Katrina fountain before McClemens, even though we put McClemens before Katrina fountain in the queue order. But it still goes to the Union exit last because you put that as your final destination.
So, any questions? Well, don't raise your hands all at once.
Is there like an overlay, like an image overlay that says what path is travelable, or is it just like grass?
Right now, we're representing each node in a file, and we pull that information using our code, and we represent those nodes onto there. So it's all in a file somewhere. And
what makes it travelable, like you can't walk across the grass?
Well, you can walk across the grass if I were to put a node in the grass. You see, the way we have it set up now, when I did nodes, I put them on intersections of roads or on entrances and exits of buildings. So if I had nodes like right over here, and you wanted to go to this building, then it disappeared. But if I had a node like right here and you want to go to this building, then it would see that as the shortest path, be like, okay, I can walk here. So we might make another checkbox that puts nodes everywhere for people that like to walk across grass.
I think y'all did a great job from midterm. Yeah, it's amazing. It's awesome. And you plan to continue before 12?
Me personally, I'd rather sign up for, I have another class I can have my eye on, and I only have one more elective space. But in my free time, I would love to continue work on a project like this. And I mean, we already have so much done that I'd be ashamed to abandon it at this point.
Mm-hmm.
Yes?
How does it look on a mobile web browser? How does it scale?
Well, that was actually one of the, somebody's going to ask me the challenging parts we had in each project. That was the most challenging part for me. I think, is it on there?
I can't really show my phone with the projector.
I know, you pass it.
If you guys have smartphones, you can pull it up.
Yeah, go to the website.
If you have a smartphone, if you just add mobile to the end of the URL there, then that will bring you to the mobile page.
You should be able to pull it up. It scales a little well. This is my first time working with, I did the website design, and this was my first time working with mobile apps, even web apps. So it does look okay in my opinion. The layout's a lot different. It's not nearly as big, but that's for you guys to look at. We can't really control it.
If any of your phones break from loading, that's not our fault.
One thing I'd like to comment, I like how you kept the 0 offset there.
The what?
For the nodes, it's 0 offset.
Oh. So,
Sometimes the mobile version does have an issue with stretching the image, depending on how the canvas renders. Also, we didn't get it working on all phones to be able to move the map with your finger, but the directions are working.
so in closing, I think it's pretty cool. Yes, sir.
Can you give me a description of the architecture that you implemented and how the mobile version of it differs from the full browser?
Would you like to pull up that image? We made an image to represent this. It's not a very good image, but it's an image.
To be honest, the mobile version is actually almost the exact same layout as the desktop version, but the CSS is different.
So if you have any architectural questions, as you can see.
So where's the logic for the routing?
A lot of the routing is in the PHP code on the server. The HTML makes an AJAX request to that and is returned a JSON string that tells it which points to go.
That's what I'm talking
Okay.
about. Now, for the mobile version, are the queries the same?
Yes.
Very good. So you didn't write it twice.
Yeah. The mobile version just has a different CSS file.
Have you guys thought about something like Google Maps? You know, you load a small picture, and when you zoom in, you have a larger picture of the same dimension.
I was thinking about doing that. I mean, we kind of ran out of time before that, but I was thinking about actually rendering it in small portions instead of one big one. It would actually help in the loading times probably.
Yeah, it would also help in the mobile device. You don't have to think about loading a big picture in.
I have a question on the traveling salesman algorithm portion of it. Or did you try to come up with a generic works on any map algorithm, or did you make an algorithm specific for this map?
I implemented a generic solution that will work as long as you have the data represented the way we do as nodes and connections between them.
And where did you get inspiration from that? Because I know this is a problem that's been knocked around by mathematicians for years.
I just used a fairly simple brute force solution that makes a tree recursively and keeps what it's found so far to be the shortest, and only keeps looking if it looks like the current path it's evaluating might be short.
Okay.
So for the mobile version, it obviously makes sense to have it updated as you walking through the campus. So what steps do you think you have to do to get that feature, and what are the major difficulties?
At the midterm area, we showed off. We had GPS services for the phone. It was able to pull GPS coordinates off your phone and put them on the web page. Unfortunately, we ran out of time and we weren't able to include that in the actual mapping GPS coordinates to nodes. But in the future, we'll be able to do that. It was also able to update your location as you walked. It would say every 30 seconds or so it would update your location. We should still be able to do that. All we need to do is map certain coordinates to different nodes, and we'd be able to, a user would just be able to pull it up on his phone, and it would say you're near here, and you'd be able to go, wherever you want from there. But we didn't have time. We ran out of time. It was a little bit over the scale of the project, so.